Hello, my name is Varnell Pritchard and I'm a digital design major here at Whole Source Community College. And today in this video, I'm going to give you an in-depth look at color perception and color physics and give you a much more in-depth look at how it is since there's many misconceptions about color in the world today. So shall we begin? So in order for you to understand color, you have to understand that color is nothing more than light. It's not a physical substance. It doesn't have any physical properties to it. So the color red is the highest that we as humans can see. It comes in at 700 through 635 nanometers, while violet is the lowest light color that we can see, which comes in at 450 to 400 nanometers. So what this is saying up here is that color isn't a physical property, it's nothing more than light. Color can also be suppressed or enhanced. Depending on the environment the object is in, the color could show more or less. In the case with the orange, we see that we can see the color a lot better in the daytime than in the nighttime. And in the case with the lime, we can see it also a lot better in the daytime than the nighttime. So now that we understand that color is just a light, that it's not a physical property, I'm going to stick my hand in this bucket of paint that's the color blue, and I'll show you how it is not a physical substance. So, as you can see, I'm touching a substance that's just giving off that color blue. It's not something that I can touch, it's just giving off that light, that unique wavelength of the color blue. Now that we understand that light isn't a physical substance, that is just something that's giving off that color in different wavelengths, the light will enter the eye through the retina, and then it will go straight into the cones and rods. Now the cones and rods process different types of light. Our cones and our eyes only see color, while rods only see in black and white. And from there you can see that it'll go straight to the brain. That information will go straight to the brain, where the brain will process it and tell us what we see. So this process is very similar to how our pain receptors send messages to the brain. Now, you may be asking, what happens if cones and rods aren't there, or they're messed up or damaged or destroyed? I'll be giving you an in-depth look at how that process is through an interview with Professor Reese Sad. I'm here today with Professor Reese Sad, and he's going to give us a little in-depth look at how somebody with color blindness lives in the world today. So we'll see his color perception through the way he sees it. Now, how you doing today, Professor?
I'm doing great. How about you?
I'm doing well.
Cool.
Now, for today, I have 6 easy questions for you to answer, because you have color blindness, and this project is dealing with how people with color blindness, or regular people see with how they see color with their color perception.
Sure.
I wanted to ask you, when did you find out that you was colorblind, and how did you find out?
Well, it took a while, because I'm not, traditionally in color blindness you have red and green problems, where those colors don't get seen very well. There are occasionally people who actually are monochromatic, where they see literally in black and white, in grayscale. But there are a lot of folks that have a deficiency in the eye where they can't see reds and greens, and so therefore it becomes noticeable pretty quickly that when you start teaching children who are colorblind about colors, well, I see colors. I just don't see the colors the way you see colors, and that's because my eye doesn't perceive some tones of green. Some tones I see completely well, others I don't. So because it's such a slight and odd color blindness, the result was that when I was growing up, people just thought that I had a learning difficulty. At about 30 years old, I decided that I was going to try to win one of my big dreams in life was to fly a helicopter. I've always wanted to fly a helicopter. Still is actually one of my dreams. So the thing is, you can't just go and take helicopter flight lessons. You have to learn to fly a normal fixed wing plane first. And in learning to fly a fixed wing craft, I was given tests for night vision, and that was when they identified that I was truly colorblind. So it wasn't until I was literally in my 30s.
So what color variations do you see compared to us? Like,
I see all colors except certain greens. So for example, now street lights are made with LEDs. They used to be a piece of green glass with a iridescent white light bulb behind it illuminating green light. Right? It would what you saw was green. I could see a green light like that. But then they started putting out LEDs, and those are white. So I see a white light instead of a green light on an LED stoplight. So when I'm driving, I navigate by the color, by the position on the lamp rather than the color that's coming off of it.
I have a little color blindness test.
Sure.
I don't know if you mind me doing this with
Not
you.
at all, not at all. Number these so you'll be able to.
Yes.
Okay, on slide number 1, I only see dots. I see no pattern whatsoever on this one. Basically see some kind of shaded, and I could kind of put together that maybe there's the numeral 8 here, but or 9, but I can kind of see around. I can kind of see something around here and there. Now, interestingly enough, that's another part of my condition, is that when things are in my peripheral view, I can conceive of color a little bit quicker.
Remember we was talking a few weeks ago about the Greeks and how they perceive color? That was a little bit different than today, than what they would see.
Well, I was reading an article probably about 6 months ago about color blindness in Greeks, in the traditional Greeks, Plato, those folks, back many years ago, and that they referred to things. I think it is Plato. It's either Plato or Socrates that refers to the ocean, an ocean the color of wine.
Yeah,
it's like, why it's blue, or if you're in the Mediterranean, it's a blue-green apparently,
yeah.
But certainly not the color of wine, right? So that there were chromatone, they think that there actually was a genetic thing that all the Greeks had an issue perceiving some colors. So there was a question about whether or not that means that literally they all had a genetic disorder, or if they just had not a consciousness.
Now, I just want to say thank you for giving me this interview today. It's really insightful that we get to see color perception through somebody who's colorblind. So just thank you for your time, and thank you.
Oh, you're welcome, and good luck on the project. It's very interesting. I look forward to seeing it when it's done.
Okay, now that we've come to the end of our video, let's do a short recap on what we've learned here today. Today we've learned that color isn't something that we can physically touch, because color is nothing more than light. So we cannot touch it physically, we can only see it. And in it being light, it comes in many different wave frequencies. So we can see red as the highest and violet as the lowest. And in it being light, it is processed through our eyes, and when it is sent to our eyes, our rods and our cones process that information, and then it is sent to the brain, that information. And for many special cases, there are people that is colorblind, so their rods or their cones is damaged. And that led into our interview with Professor Reed Shad, which he told us how his daily life is impacted with being colorblind and how he has a unique case of it. And then so, I hope that you've learned much about color perception, color physics, and that it isn't something that we stereotypically thought it would be, that is something unique and diverse. So I just wanted to say thank you for your time, and I hope that you learned something here today. Thank you.